that thing that we just saw? Well, I'm about to show you. This is a jig that I made from pretty much standard stock 80-20 parts. If you don't know what 80-20 is, it's all of this extruded aluminum stuff and all the different accessories that go along with it. So first, let me show you the actual parts that we're starting with for this jig. I've got this extruded aluminum here, and this is the standard size, and I'll just measure it here. It's 1 inch by about 3 inches. I believe they're sold as millimeters, but whatever the equivalent of that is. And I have 2 of those that are 38 inches long. I picked that size for my purpose, but they could be any size really. And that's for the length of the jig, and then the width of the jig is controlled by these guys, which is the same 1 inch by 3 inch, 10 inches long. And then I've got some of the smaller stuff, which is basically the 2 inches wide by 1 inch, and I've got these for stops if I need them, 14 inches, and then these two are 2.5 inches. Now, holding all of these things together is all of the hardware here. But these are the T-nuts, 1/4-20 T-nuts that ride in the tracks. These are the bolts, 1/4-20 bolts with like a hex head that then tightens them down. These are additional T-nuts, so that's just an extra amount of those guys over there. And then we have 2 different brackets. We have an angle bracket, which is going to connect a lot of these pieces and parts together. And then we have flat brackets that's going to create a stop that goes down into the track area with this smaller piece there just to stop movement if I want to build in a certain stop range. Depending upon what I'm doing, I may use it, I may not use it. All right, so we have 8 brackets, 4 holes in each, so that produces the 32 screws. We have 2 of the flat brackets. That uses kind of a flanged bolt here, and 8 of those for those 2 brackets, and then obviously 40 in order to equal 1 T-nut for each one of those. So we're going to start assembling these. This is going to be the underside, and the underside is going to have brackets kind of holding it in place, and I'll put those on the outside of it. Alright, so a lot of screws, but this is the underside. So this jig is going to sit on my router table right here and allow me to pick a line that I want to make a straight cut. and this will clamp to the underside of the table to hold it securely. These will slide left and right so that it basically squares up on the table, and then that, when it's right side up, you'll be able to see that then these guys will be able to slide left and right, and that will be used as a stop if I need it. There'll be some things I'll use it for, there's some things I probably won't use it for. So let's go back to the router table and see how this all fits on. And as you can see, we've got the long rails, we've got the shortest rails that are on the underside, and then we've got two stop rails. So I can position those wherever I want, and that creates a stop for doing routing work that doesn't go all the way through from one side to the other. I've got a 1/4" spiral bit installed, and I'm just going to do a test cut. The rails are certainly adjustable with this 80/20, just like these are adjustable, then can be locked down with a couple screws on either side and a standard 5/32 Allen wrench. So it's pretty cool stuff. So let me show you some of the details of this first. You can see the stop rails and how that little tiny, like 2.5 inch long piece is joined with a flat plate to the other side, so that that extends below the cross brace down to the surface. So no matter what thickness of board I'm using, down to 2.5 inches wide, that can be installed and used to stop the travel of the piece of wood. If we go on the underside, using this 80/20 and a couple 1/4 inch toggle bolts, I was able to put a system to lock it to the underside of the table. Holds it very securely in place, which is nice. All right, I'm going to do a through cut that basically goes from one end almost all the way through. I've got this one stop set up, and I'm just going to leave it stopped just to give you an idea of what the purpose of that is. Well, let's get this going. So there's a piece of wood that I just ran through, and if you look, we just kind of went in that one side and made a perfectly straight cut all the way about to my line, which is where the stop was set to. So that is looking pretty sharp, looking very clean, and when you have support for that wood on either side, it's a very safe cut because there's no way that that wood can get kind of grabbed out of your hand and pushed across. If we want to add a secondary stop, let's do that on this side. Then I can just reposition this to stop when the line that I want gets right to the edge of my pencil line. Now what I did here was I made a center line which was centered on the middle of the router bit, and then I made two other lines, one on either side, to the dimension of the bit. It's about a 1/4 inch bit, so I made those lines so I know right where that should stop. So this will have to be a plunge cut, and that'll start right there, and we'll shift it over to the other side, and we'll get that perfectly done. So it's kind of an elaborate jig, but it is very strong, very rigid, beefy, and extremely adjustable for multiple widths. I just loosened up the bolts from this, so I'm going to actually remove those brackets and set them aside. Why use the stops? All right, you don't always have to use the stops, and in some cases for longer pieces of wood like this, where I'm going to stop here and I'm going to stop there, I really have a travel that's going from this side, which extends past, and then all the way to this side, which doesn't give me quite the room that I need to have my stop on that far end. So you don't always need to use the stop, but it is a good idea for repeatability for the small pieces that you might have. In this particular case, I have the beginnings of what is going to be a Fender style guitar neck, and I'm going to put multiple channels in here. The first one with this particular bit, which is a 7/32 wide spiral bit, I'm going to do a cut right down the center. So with using my reference points here, I can turn this board upside down and I can see where that alignment is, and I can start it right at that first alignment point, and then I'll slide it all the way up to my second alignment point, and we should have perfect placement of our truss rod in this particular guitar neck project. Now, the double rail system was a hold down that I came up with when I was really looking for a positive, secure way to do some slot straight line routing. And my first iteration of this was just out of some scrap poplar wood that was lying around the workshop. I didn't make it as long, so basically it had to go crossways like that, but I would use clamps to clamp it down to the table, and I could adjust the width to get the desired width I need to trap that piece of wood, i.e. my guitar neck, on either side. And then I could put stops in there either manually, by trying to put a clamp across there or something like that. Or what I did is the same that I'm doing here, is I'll draw the center line on this piece, and then I've got the markers on this piece where my stop points are, and I will just pass it through until I see those lines match up, and I'll pull it off. I'll increase the depth. I'll do 2, 3, maybe 4 passes, and I'll get the desired depth that I need, which is going to be 7/16 of an inch. So let's go ahead and do that now. Now with the truss rod for this guitar neck done and that slot cut out at the right place, I can slide that in, drop it down, and there's perfect routing. So as you can see, the support on either side almost makes it dummy proof. I can get this at the perfect length. I can go nice and slow to get to the perfect depth, and I'm going to have a perfect fit every single time. That's consistency, and that's what I like out of my jigs. All right. Till next time, remember, no matter what you do, start with excellence.